Hey there everybody, this is Miss Q. Today we're going to be doing a lesson from 4-2. It'll only be day 1 today. You'll have time to practice in class. I got called out for jury duty. Hopefully I'll be back tomorrow. If not, you'll have another video for part 2 tomorrow. And the good news is that you have no work to attach and you'll have time to do your homework in class today. Okay? So let's make sure we learn it really well so you can get 100% on your assignment. All right, so the first place we're going to start is by looking down here. Okay? So today our important terms are going to be monomial. So a monomial is a number, a variable, or a product of a number and one or more variables. Okay, so our book is giving us some examples over here. 6y squared is a monomial because it is a product of 6 and y squared. But if you look at this expression here, x plus 3, it is not a monomial because it has that plus sign, right? So it's the sum of two different monomials being added together. Whenever you have addition or subtraction signs, like in this one above here, that separate an algebraic expression into parts, then each of those parts is called a term. Okay, so these are important words for us so far, monomial and term. We're going to use them. A monomial only has one term, so the expression x plus 3 that they showed us earlier is the sum of two monomials, therefore it cannot be a monomial by itself. So what you're going to practice right now is they're kind of giving you like a number bank right here. You're going to click pause and you're going to try putting each one of these into the appropriate bin that you think it belongs in. And then there's samples already done for you. Okay, so take a quick pause and try them out by yourself. Okay, hopefully you tried them. So x would be a monomial, right? Because it's only one term. The number 80 doesn't have that plus sign, right? So it would also be a monomial. X squared minus y squared, definitely not just one term, so we can put that one here as not a monomial because it had two terms. 8x, even though it has two different pieces to it, is still a monomial because it only has that one part together, right? X times the 8. And then x plus 5 is not a monomial, okay? So one term versus more than one term. All right, now that we know our vocab, let's flip it over to the next page here, okay? So over here, our book is going to be teaching us a really important rule for how to find powers of products. They give us some really good steps here. And I also kind of liked the video that our book included, so we're going to try and watch that real quick. Hopefully it'll work for us. Okay. All right, so that's a really cool shortcut that we use, okay? So instead of writing them out individually and then counting all the factors, the shortcut our book is teaching us can be modeled down here. And for our notes today, when we're writing in our stuff, I'm going to ask you to write it in like this. So you can memorize that because they have the same base, we're simply adding the exponents together to get our final simplified answer. But for your homework, you don't have to write that out unless that works for you. Okay, but for our notes, let's write them out the long way. And then over here, our book is teaching us the rule. So I'll give you a minute to kind of highlight your text, write in our simplified answer, and you definitely need to memorize this rule, and it's called the product of powers property. So the group of integer exponent properties, including this property, is called the law of exponents. So throughout this module, we're going to be learning all about these laws of exponents and adding more new properties as we go. Okay, so here is showing us our shortcut rule that when they have the same base, we are simply adding their exponents together. If it's a variable for our base that's unknown, we can model it like this. If it's a number for the base, like this one that we know, we can model it like this, and we would simplify it with the same exponent to read 2 to the power of 7. Okay, so now we will get to work with example 1. So over here at the top, I really like that our book showed this, okay, because we talked about this in class yesterday, so let's mark our text. If they ask us to simplify, what they're going to say on your homework is simplify to 1 exponent, okay? So this is 5 to the 4th times 5, and I want you to notice how our book wrote it. Do you guys see how they took that 5 and they wrote it as 5 to the power of 1? So this comes back to our lesson yesterday where I pre-taught you that every base can be written as an exponent. So if there's no exponent next to it, the way it was here, then you need to write it as 5 to the 1st to remember it. Here's why it matters. Because once you put those together and use the shortcut we just learned, you're going to add the 4 plus 1, and 4 plus 1 makes 5, right? If they ask you to multiply it all the way out, you would multiply 5 to the power of 5 using your calculator. But if they're just asking you to simplify it as 1 exponent, then you would leave that as 5 to the power of 5. Okay, and your homework will be specific when they ask you. And we're not using a calculator in class today, but you will definitely be allowed to use a calculator on your homework if you need to. All right, so let's have you try this one on your own. Take a quick pause, and remember, show your work like they did up here so that your notes make sense to you. All right, that one was nice and easy, so let's write it out the long way if you didn't. Because they have the same base, the rule or the power that we learned here is taking that same base, writing it 1 time, and simply taking your 2 exponents and adding them together. If they ask you to multiply it all the way, this is what it would be in full simplified form. If they ask you to write it using a simple 1 exponent, then it would be 4 to the power of 8. All right, moving forward here to example 2. So same idea, but now we're looking at algebra, meaning that we don't know the value of that base. So in this case, our base is C. And because both of them are a C, that's where we can use that shortcut that we learned today. So when we see simplify, that means we're going to just simplify by writing it out with the same base. So look and see how our book is showing the work over here just for our notes to make sure we understand. We're simply taking those exponents of 3 and 5 and adding them, right? Because it's really like saying C getting factored or multiplied by itself 8 times. All right, so let's have you try the next one. And of course, take a quick pause and write it out as a math problem for your notes so that if you need help later, it makes sense to you. All right, hopefully you paused it. These are nice and easy, right, to start our rules. Because they have the same base, the shortcut that we learned is we simply take those exponents. We can write it as an addition problem. The base stays the same, and we're really saying that there's just 10 of those x's being factored or multiplied together. All right, so you can see why there's no work to show here, because this is really just teaching you to practice these rules so that then we can get a little higher level with them as we go through the week. All right, so now here's what's different in example 3, and we should be on page 234 now. On this one, what we have is we have coefficients also. If you remember from elementary school, coefficients are the numbers that come before the variable. Okay, so in this case, the -3 and the 4 would be your coefficients. Okay, but I want you to notice that they both still have the same base of x. So when we're being asked to simplify, we don't know the value of x, so we can't solve it. That's why we're just going to simplify as far as we can. All right, so let's go through this one together. So the first thing our book is showing you is the coefficients right here. It's kind of breaking it into pieces. Okay, here's that word in case you're not sure of how it's spelled. Okay, you should have learned that a lot in 6th grade. We'll talk about it a lot more this year. They're showing you using your commutative and associative properties, we can group our coefficients together. we can group our bases together just to help you stay organized. When I multiply a negative 3 times a positive 4, I get my negative 12. So let's write that in together. According to our rules that we learned today, x squared times x to the 5th, they have the same base, right? So we do plus with those. Gives me x to the power of 7. So when I put that together, it's negative 12, x to the power of 7. And do you notice I'm not even putting like a raised dot there? I'm just writing them next to each other because having a coefficient next to a variable automatically implies multiplication. You don't have to put an extra raised dot or multiplication sign there. And of course, always remember to include that negative, right? All right, so now it's your turn. Let's have you take a quick pause and try to simplify this one. All right, hopefully you wrote out some work to help you if you get stuck. And of course, tonight there's no work to show. If it helps you to write it, you always can. But I want you to write it out this way on your notes so that if you do get lost, you know where to look. So just like our book showed us above, I separate my coefficients. Negative 2 times 3 coefficients get multiplied to make negative 6. And did you guys remember that little trick I taught you about the a, right? It's not just a, it's a to the power of 1. Because they have the same basis, I'm really adding my 1 plus 4 together, and my simplified answer is negative 6, a to the 5th power. And remember, if you don't include that 1 there, it might give you a different answer when you're working through it. So remember, if they don't give you a variable that has the exponent next to it, right, then you know that that variable automatically has an exponent of 1. That was one of those imaginary ones that we talked about yesterday's lesson. That's always included. All right, so now that we did multiplying, we're going to look about quotients. And if you remember, quotients are just a fancy way of saying division, all right? So here our book breaks it down. You'll see that this time it has that fraction bar. And just like I taught you before, the fraction bar automatically means division. So our book does a nice job breaking it down for you, but I also feel like the video that they have is kind of nice. So let's check this out. Hopefully I'm on the right video. All right, so let's check this one out. All right, so that was pretty cool. What they're doing is just flipping what we did to the inverse, right? So you would never need to write all of this out, but what they're doing is trying to show you why this shortcut works. So it makes sense that if the shortcut for multiplying was that we added the exponents, that if you're now dividing, right, and you have the same base, instead of adding them, you're really taking the 6 and subtracting the 2 to get 3 to the power of 4. And the cool thing is by writing it the long way, they're showing you how they cancel each other out. Okay, so over here, our shortcut that we're going to memorize then is, again, if you have the quotient and they have the same base like this, what we're really doing is taking that base, rewriting it, and we're subtracting the exponents from each other. Okay, so whenever they have the same base, we subtract it. This is another one of those rules that we're going to be memorizing, those laws of exponents. So let's take a second here to highlight our rule. This is the quotient of powers property. So this is our second property that we're learning in this lesson today. And here's that important rule so we can reference it later on. It's showing you how this works algebraically, as long as your base is not equal to 0. And then it's showing you how this works numerically if you have a regular number for your base And of course, recognizing that 7 minus 3 makes 4. Okay, so on your homework today, you're going to have an introduction to both of those. So now let's try it. All right, this will be our last example for today. So looking up here, our directions again don't say solve, right? We're just simplifying because we don't know the value of x. But I do know that the fraction bar means division and that they have the same base. So our book is showing us our shortcut here, right? We're taking that base of x and saying 8 minus 2 makes 6 when we subtract our exponents. And this is what it looks like simplified when we write it out. All right, so let's have you try this next one by yourself over here. Take a quick pause. Now that you tried it, again, I like to show you the work for your notes, so try and write it out this long way. You, of course, don't have to do that on your homework, but it's nice in your notes to have that reminder. Because they have the same base, I'm able to subtract the exponents, and I get z to the power of 8. And just for fun, let's do one more. All right, so let's have you try this one by yourself. Hopefully you took a quick pause over here, and remember the focus is on looking at things with the same base. The x's had the same base, so we can think of it as x to the 8th minus 5. The y's had the same base over here, so we can think of it as y to the 3rd minus 1. And when I simplify that out, I get x cubed y squared. And of course, we learned yesterday that when I write these out, I don't need a raised dot there. I could put one there if I wanted to. And of course, we always try and write it in ABC order and using our exponent notation in our McGraw-Hill toolbar. So that's it for today. Keep your notes next to you, so if you need to reference them during your lesson for your homework, you can. And then of course, let's go ahead and open up our McGraw-Hill and let's try and get 100. All right, have a good one every day. Bye.